blockchain very literally is a distributed append-only database, which means, so distributed meaning that all the entries are dealt with and verified by a network as opposed to a single admin. And append-only meaning that entries cannot be altered, modified, deleted, whatever, after they've been made. You can only add new entries onto the database. So Bitcoin is the first implementation of this, and it's value transfer through blockchain. Right now you trust, say, banks to do value transfer for you. You do a wire transfer. You're trusting the bank to properly handle that, regulatory, the literal exchange, all that. With Bitcoin, instead of dealing with a financial intermediary, I am sending directly to, person A is sending directly to person B. And the verification that that happens legitimately and efficiently is done by a distributed network of, I don't actually know how many computers are doing this on Bitcoin, but it's tens of thousands, if not hundreds of thousands. So the next important thing is Ethereum. And people might get mad at me because there are more other important projects, but I only have 5 minutes, so bear with. So Ethereum takes blockchain, and instead of just doing value transfer like Bitcoin does, it actually distributes, it takes the role of executor of computer functions and computer code and distributes it over a network. The blockchain thing, it's distributed and append-only. It's a sort of global computer, because instead of like, if you have a Gmail account and you send an email over that, it goes to Gmail servers, and then whatever you're sending it to stays in Gmail, or maybe it goes to Hotmail, whatever. It's being taken care of by an entire global network. This is relevant and valuable because Gmail can be hacked. There's a central point, I mean, anything can be hacked, but Gmail is an easy target because it's centralized and there's a specific point of failure. People can go and they know, okay, I'm going to attack Google. With Ethereum, like Bitcoin, there's tens of thousands, if not hundreds of thousands, of computers on the network. So you can attack some of them, or you can try and take over the network. There's different ways that you can go about such things, but it's complicated, much more costly, making it ultimately much more secure than a centralized server. So some use cases for blockchain. Value transfer, that's Bitcoin. Code execution, that's Ethereum. Identity. I know some groups that are trying to make it so that you can just have, instead of passport, you can have your identity on blockchain, and when you go through integration, it's as easy as, I don't know how often this is really done in the States, but it's just paying for something with your phone like an Apple Pay. It's that simple, you just put your phone on, something like that. Financial products, that's an obvious use case. People are trying to make derivatives. People are obviously replicating things like equity or debt. Deloitte just published a paper talking about how this could be used for loan origination and securitization, because you could have a standardized set of rules and it's immutable and it's much easier to track. So this is a global database. Governance, I'll touch more on that in a sec because I'm going to get to my own project. And then file storage, because it's a database, it has obvious implications in file storage, and if things can be done more cheaply and efficiently, because then that can really revolutionize how file storage works. So our project, it's plural because George was supposed to be up here with me, but my project is called Vega, and it's an Ethereum-based project that ultimately we're seeking to make a mechanism for autonomous decision-making that takes information and bases decisions from a global network. So you're getting a vast aggregation of information that's also powered by specific economic incentives. And that's what people are using Ethereum for a lot, is building these tokens I'm sure people have heard about that are meant to have specific economic incentives driving behavior. The immediate use case of this is for funding. So like in Ethereum right now, I'm sure people have heard of ICOs, initial coin offerings. That term blows because the SEC will jump on it. It sounds like it's a security when often it's just software. But point being, the immediate use case for this is, okay, well, we can derive funding decisions from a network. Later on, this can be used for governance, like in the last slide, the concept of futarchy, which is decisions made based on prediction markets. And that's more than I can get into in 5 minutes. But point being, the ability to easily tap into global networks of value or knowledge or file storage has huge implications, and that's what we're dealing with here. So that's all I've got, and I'm open to questions.
Questions?
Yeah, so what does blockchain have to offer in terms of value added for autonomous decision making? Like, is there an AI involved, or what's going on?
Yeah, so the idea that we're trying to make is, blockchain aids this because of the global nature of it. It's not, this is something you can actually do without a blockchain. That's what prediction markets have historically been in like the mid-2000s. But the idea is that if you can get, because think of like with stocks, how you have to be an accredited well, not for stocks, but you have to have a fair amount of capital. Venture capital, you have to be an accredited investor. And there's a high barrier to entry. With something like this, you can sell membership, or you can give membership into a decision-making network for fractions of a penny. And you can do it globally with ease. So you are able to aggregate a lot more information, which the idea is that combined with incentivizing high-level knowledge and higher professional information to come forward, and this is prediction market stuff more than specific blockchain stuff, then you can source really, really good decisions. And there's a lot of literature on prediction markets and how they're actually better than experts when it comes to forecasting and decision making. But the blockchain part of that is mainly just the global access.
Is this similar to Augur and the rep tokens?
Right, so Augur and another project called Gnosis are the big prediction market platforms in the space right now. And I really like both projects. I actually love the concept. I think they're great. The difference between what I'm doing and what they're doing is that they're actually a specifically prediction markets platform. So it's about going on there, you make a market, people can trade that market, and you're just trying to forecast. Well, it's actually kind of like a sports book. You're really just market making. Whereas my thing is this concept of futarchy, where you're doing the forecasting and you're doing the prediction market stuff, but you're immediately implementing and acting on the information gained.
Okay, so there's like a decision layer on top of the prediction market.
Exactly, yeah.
Are you planning to monetize this in any traditional way, or just keep it all ether?
In any traditional way?
Yeah.
What do you mean by that? You mean like traditional venture capital, or?
I mean like, yeah, monetize it with some fiat currency at some point, or keep it strictly.
Yeah. So the issue with that is, and I mean, there's a whole host of regulatory issues that haven't even made themselves apparent yet. But the immediately obvious issue with, say, taking fiat for the platform is that then you are very, very, very clearly subject to a lot more legal scrutiny.
Last question.
What's the last question? Basic question. If the blockchain is byte only, why doesn't it get too big?
Well, I think that's actually a big argument. I don't think it is a big argument. That's something that if you read some of the stuff that the guy who founded Ethereum, this guy Vitalik Buterin, that he puts out, he's saying it does get too big, and we need to be able to maintain how secure it is and how efficient it is without forcing people to maintain this huge database on their computer all the time. There needs to be, I think it's a light client, a light node. I'm screwing the terminology up, it's something like that, but just saying you're verifying only a portion of this entire database and still maintaining the integrity of it.
Awesome. Thank you very much.
Good.